everything together today. We've been on a long journey as far as calculus is concerned. This is our 8th and final lesson on this particular topic. But don't worry, we will come back and revise calculus. I'll also do plenty of revision with you before the exams. I'm talking about your June exams as well as your trials and finals. I know some of you have already started writing June exams now. So we are starting a revision course next week, just sort of tying everything together. Hopefully your exams are not this week and you've missed that, but anyway, what can we do? All right, so what I wanted to do is just tie everything that we've spoken about, from factorizing cubic expressions, solving cubic equations, finding the equation of a cubic function, sketching them, etc., etc. I want to tie it all together in the analysis type questions that they're going to give you in tests and exams. All right. The other thing, it's all right, Sejo. Right, this will help as well. Okay.
All the best.
Yeah. No, I think there's a lot of people that are writing paper 1 tomorrow, the 2nd of June, and then again on Monday. Sejo, you're writing paper 2 on Monday, is that correct? Okay, well, let's just have a look. Yes, okay, all right. Anyway, this will help. And at least you've got the wizard to use over the weekend as well if you encounter any problems. But remember, we still will be here after June. It's going to be a good idea for you to attend classes in any event. We can go back to previous questions and concepts, etc., and make sure that you guys are okay. I mean, one of the issues I think all of us face when we write exams is the fact that we get examined on work that we've done such a long time ago. So, if we work during June and we work during the holidays, then at least you're going to stay on top of all of those things that you've done a long time ago, because your teachers are not going to be able to go back and teach you all of that again. Okay, so let's have a look at the first question. We have the graph of f of x. It is ax cubed plus bx squared plus 24x minus 20. The point A, 2 and 0, is a local maximum turning point. B is a y-intercept, a y-intercept, and C is an x-intercept of D. D is the local minimum, and E is the point of inflection. All right, so the first thing that they want us to do is calculate the values of A and B. So this is what we were practicing on Tuesday, all right? So they expect us to be able to answer this question now, right? Any ideas as to what you think it is that we should do? How would we calculate the values of A and B? Anybody give me any suggestions on what you think we should try? How would we go about calculating the values of A and B? Okay, so in other words, this A over here and this B over there. Remember, there were a couple of concepts we spoke about on Tuesday. Just want to see simultaneous equations. Yes, we probably are going to have to use simultaneous equations. Any ideas? Where would we start with a question like this, Matrix?
Uratile is giving some hints on the charts.
Okay, so Oratile says, first get the value of A using x1, so x minus x1 and x minus x2. And Lindelwa is saying we need to derive. Okay. All right. If we use the first method, all right, we would have to use y equals a. We don't know the value of a. X minus x1 times x minus x2. And then we would need to square the bracket where we're going to substitute in the value of a. Now, the problem here is that there are lots of unknowns, okay? But let's see. I see they're asking us for the coordinates of B over there, which means we shouldn't work them out in this question, but perhaps we can do it this way as well. Remember the coordinates at B, the y-intercept. Can anybody tell me what they are? Can anybody tell me what the coordinates at B are? Looking at the equation, what are the coordinates at B? 0 and -20, absolutely. Okay, but they don't want us to use this point just yet because it's the second question. All right. Do we have enough information to do it this way? Well, let's sub in and have a look at what we've got. So we've got y equals a, x minus, now x1, we don't know the x coordinate at C. So let's continue to call it x1. We know that at A, it's +2. So when we sub that in, we would square it. Okay. Can you see that at this point, we have got too many unknowns in order to be able to do this? What we are missing is a point on the graph to sub in for y and x. And the other thing that is unknown to us as well at this point is what our other x-intercept is. And we can't calculate it because we don't know what the coordinates at C are. All right. So unfortunately, even though this is true, this particular method at this point is not going to help us. All right. Everything that we've written is true, but it's not going to help us solve a problem. So the second suggestion that was made, all right, where we should derive is going to be the way to the answer in this particular problem. Okay. So Lindelwa, you said derive, okay? So if we go along and now we derive, we would end up with f prime x equals 3ax squared plus 2bx plus 24. Okay. We do have a point that's been given to us. We've been given A. And A is a special point
Is
for
this
us because it's an
this
x-intercept and it is a turning point. Okay, so we know that the gradient at A is 0. So we can sub 0 in here for gradient. And we know what the x coordinate at the turning point is. So we can sub in our x coordinate as follows. This then gives us 0 equals, that's 4 times 3, so that's 12a plus 4b plus 24. And I'm going to take the 24 over to the other side, so that would be -24 equals 12a plus 4b. And I'm just going to leave that as equation number 1. So somebody said we would have to do this simultaneously. All right. How are we going to make the other equation that we're going to need? What would we do? How would we make the other equation that we need? Think back to Tuesday. What did we do when we were given a point that was a turning point as well? So one thing was to use the derivative. The other one was, can anyone remember? There we go, Mamelo. Perfect. Okay, we need to sub the point into the original equation, so the original f of x. Okay, so we're going to sub the point A, which is 2 and 0, into f of x. So that gives us y is 0 is equal to a x cubed plus bx squared plus 24x minus 20. All right, so now we've got 8a plus 4b plus 48 minus 20. So if we now combine our like terms together, this would give us 8a plus 4b, and 48 minus 20 is 28. Let's take the 28 over to the other side. So we've got negative 28 equals 8a plus 4b, and their matrix is equation number 2. Okay, all right, and now we're going to have to solve simultaneously. All right, so you can choose. You can solve by substitution, or you can solve by elimination. I don't know if you recall us talking about the elimination method on Tuesday. This is a nice one for elimination. If I put negative 24 equals 12a plus 4b up at the top, and negative 28 equals 8a plus 4b down at the bottom, the coefficients of my b terms are the same. So I can eliminate by subtracting the equation at the bottom from the equation at the top. So if I say minus 24 plus 28, I'll get 4. And if I say 12a minus 8a, I'll get 4a. 4b minus 4b, your b terms have been eliminated. This is why elimination is such a nice method, because you don't first have to now go and divide through by 4, make b the subject, then go and sub it in. It's much faster. All right, there's nothing wrong with doing that, but it does take a lot of time, okay, which then means that we've got less time for other things. All right, so a would be equal to 1. I am going to have to go and sub in for b. I'm just going to use the first equation. So I'm going to say minus 24 equals 12 times 1 plus 4b. Take my 12 over to the other side. That would leave me with negative 36 is equal to 4b. Divide both sides by 4. So b, by 4. So b would be equal to negative 9. Okay, so now I'm happy to take some questions. Amahle, I see you've got your hand in the air.
Good evening, ma'am.
Good evening, Amahle.
Why did we derive?
Okay, because we were given a turning point. 2
Oh,
and
okay.
0. So 2 and 0 is not just an x-intercept, it's also a turning point. So the gradient at A is equal to 0. Okay, so that's why I have this 0 over here, not because of the y-intercept. Hang on a second, let me just get my pen. This 0 over here that's in yellow. Okay, that is the gradient at that point. Okay, that's why I derived. Okay, any other
Ma'am,
questions?
I've got,
Yes.
yeah, I've got one more part to my question. So
Sure.
because the point that was given on the graph is a turning point, is that why we had to use the first derivative?
Yes, absolutely. So I don't know if you were here at the beginning of the lesson, Amahle, but I had asked everybody for suggestions on how we would determine the values of A and B.
Yes, I was here.
Okay. And somebody, I can't remember who it was, made the suggestion that we could use this formula over here. Okay. Which is the correct formula for this situation. But the problem is that you can't solve for 2 unknowns in one equation, right? So we had too much information missing and not enough information to be able to do it this way. If we had known what the x coordinate at C was,
Okay.
Then we could use this equation that I have drawn the pink circle around and have done it that way. But because that information was missing, we had no alternative but to do it this way that I was showing you the other day. So in other words, we've given the turning point, we're going to derive, sub in the 2, which is our x-coordinate, our turning point, and get one equation in terms of a or b, and then go and sub the point 2 and 0 into f of x to get the other equation in terms of a and b. Okay, so
Okay, thank you.
does that help?
Yes, thank you.
Cool. All right, no problem. Now, somebody also said that they didn't understand. What other way, Leanne, are you referring to? Non-Jabula, we can go and look at the green bit again, not a problem. Leanne, what are you referring to? Do it the other way. Do what the other way? Divide by 4. Leanne, I'm afraid I'm not following you. Oh, you mean when you solve simultaneously? Is that what you mean? Oh, okay. All right. So you're talking about substitution. Okay, that's fine. That's not a problem at all. Okay. So let's go and have a look at how we would do this if we wanted to do it by substitution. Okay. Let's just scooch over a little bit here and we can have a look at how we would do it by substitution. Okay. It's just a longer way of doing it. Elimination is much faster, but you don't have to do it that way if you don't want to, if you're not comfortable. So you've got minus 24 equals 12a plus 4b. You can divide every term by 4. You'd get negative 6 equals 3a plus b. Now you can make b the subject to the formula. So that would be minus 6 minus 3a. And now we need to go and sub that into the other equation. So our other equation is negative 28 equals 8a plus 4b. And b is equal to minus 6 minus 3a. So that gives us negative 28 is equal to 8a plus, sorry, actually it's going to end up being a negative, isn't it? Positive times a negative is a negative, so that will be negative 24, and then it will be minus 12a. So I'm going to take the 24 over to the other side. That would give me negative 4a on the left. 8a minus 12a would leave me with negative 4a. So dividing both sides by negative 4a would be equal to 1. Okay, and then you would have to go and sub back in for b. B would be equal to minus 6 minus 3 times a, and therefore b would also be equal to negative 9, just how we found it out. Okay, so if you compare the amount of writing with the green and the orange, I suppose it's not that much more. It's just an alternative way of doing it. All right, so this method over here in the orange, here we used substitution. Here in the green, I used elimination. Okay, both are acceptable. Yes, Alwetu, you've got your hand up.
So, Miss, I'm asking if we don't have a midpoint, and what do we do?
What do you mean a midpoint?
As we given 2 is to 0. What if, is there any other time we don't have even points?
No. So they have to give you enough information to be able to use one method or another. Okay, but you don't know how they're going to expect you to find that. That's why you need to know how to do it if you've been given the x-intercepts like I had in the pink, or how you'd be able to do it in this method over here where you've had to use the first derivative. Okay, but they're always going to give you enough information to be able to calculate that. You just need to know the methods.
Yes, ma'am, no problem. Thank you so much.
Okay, all right, that's fine. Okay, are there any other questions about how we would calculate A and B? All right, so that was quite a lot of working, wasn't it? All right, so often what they do with these sorts of questions, instead of just saying to you, calculate the values of A and B, because if you can't calculate the values of A and B, then the rest of this becomes very difficult. So in your exam, they will probably say something like, show that A equals 1 and B equals -9. That's more likely how they would ask it. So that if you can't do question A, you can still do questions C, D, and E. You don't need question A in order to be able to do question B. All right, so look out for that. That's what they're referring to when they say, show that A equals 1 and B equals -9. They're asking you to determine the equation of the cubic function. That's actually what it means. Okay. All right, then let's have a look at question B. They're asking us for the coordinates at B. So that's really easy. Do you remember when we first did this? In fact, somebody's already put the answers up. We had said that your constant is going to be your intercept. All right, now be careful. If they ask you for coordinates, give them coordinates. All right, so I marked the calculus question at my school. My school's already written their exams, and there were lots of boys that ended up losing marks because they didn't write their coordinates carefully. Okay, so when they want coordinates, okay, it's the letter of the point, the x coordinate first, which is 0 in this case, and the y coordinate second. So be very careful. If they ask for coordinates, give coordinates. Don't just give a value. Okay. Yes, Palesa, sorry. Can you please repeat it, the substituting? Okay, so Palesa, what is it about the substituting that you didn't understand? Can you be specific and tell me what it is that you didn't get?
Lisa, remember you can unmute and talk also.
Lucinda?
Hi, ma'am.
Hi, Lucinda.
Ma'am, I just wanted to ask. So, if you are given the equation and they give you the constant, is it always the coordinates of the unknown on the graph?
It's not the unknown, it's the y-intercept. Okay,
Okay.
so when they give you the equation in the form f of x equals ax cubed plus bx squared plus 24x minus 20, the constant, so the only constant there is minus 20, that is your y-intercept. Okay, so no problem. So if it's given to you in the form f of x equals ax cubed plus bx squared plus cx plus d, d is your constant. Okay, that is your y-intercept, always, always, always. And if the d term is not there, it means that the y-intercept is the origin. The graph goes through the origin.
Okay, ma'am. And when you're using the
the first derivative?
No, ma'am.
Uh-huh.
Okay, ask again. I'll remember my question because I forgot it, ma'am.
Okay, that's fine. No problem. When you think about it again, it's not a problem. Okay, so Palesa, all we've done is we've taken the first equation, we've divided it through by 4, and we've made B the subject by taking 3A over to the other side. All right, it's normal solving by substitution that you would do for any simultaneous solution. Okay, so you've taken the one equation, you've made B the subject, and now you've gone and subbed it into the other equation. Okay, so in the place of B, I've written what B is equal to, which is minus 6A minus 3A. and then I've solved for A. Okay. All right, just normal substitution like you would do when you were solving a simultaneous solution. Okay, now the length of AC. What are they actually asking us to calculate here? I know they want the length of AC, but what do we need in order to be able to answer this question? What does this question really mean when they say the length of AC? Absolutely, there you go. Well done, Nhlanhla. Well done, Teddy. We need the coordinates at C. We need the coordinates at C. So how are we going to get the coordinates at C? From the information that we've got. Remember, your equation is f of x equals, remember A was equal to 1, B was equal to -9, C we know is 24, and we know that D was equal to -20. How are we going to work out the coordinates at C? Any ideas? Remember, C is a x-intercept. So what do we always do for the x-intercept matrix? What do we do for the x-intercept? What's the rule? Okay, absolutely. We have to make y equal to 0. Good starting point. Okay, so we made y equal to 0. Now you've got to think back to what we were doing when we spoke about factor theorem and how to factorize cubic equations. Okay, do we know? That's it. Good. Yes, let y equal 0. Perfect. Great. Now think back to our lessons on factorizing cubic equations and solving cubic equations. Remember, what we wanted was a linear factor of our cubic. In this case, do we have a linear factor? Do we have a linear factor? The answer to that is yes, Nhlanhla. Good. You're making wonderful connections here. Look at what Nhlanhla has said. Yes, we have a linear factor because when we sub in 2, we know that we get 0 as an answer. Well done, Nhlanhla. So that means that x minus 2 is a factor of f of x. So now we can come along and we can put in x minus 2. Remember, it's our job to then work out the values of A and B and C. Okay, so if you want to do that by, what's it called, synthetic division, you can. Or if you want to do it by inspection, you can also do it that way. In this case, right, remember we know that the coefficient of the x cubed term is 1. So that means that ax cubed is equal to 1x cubed. So we know that a is equal to 1. -2 times c is -2c. And remember, we made that equal to -20. So we know that c in this case will be equal to 10. Then if you recall, to get our bx term, or our b value, we would have to multiply x with bx to get bx squared, and -2 with ax squared, so a is equal to 1. So that's -2x squared, and we know that it's equal to -9x squared. So that means that b minus 2 is -9. So b would have to be equal to -7. All right, so now we can go and fill those values in. Okay, can you see how this question is asking us to put everything together that we have been speaking about on our previous lessons? Okay, so we know that b is equal to -7, a is equal to 1, and our c value in this case was plus 10. We can go ahead and go and factorize our trinomial. It's minus 7x in the middle and 10 at the end. So both brackets need to be negative. And again, the answer that we get makes sense when we look at the picture. We were expecting x minus 2 to be squared. All right, because it's a turning point and an x-intercept. Yes, Leanne, lovely. So yeah, perfect. Perfect, perfect, perfect. So at C, x is not equal to 2. So x is equal to 2 or x is equal to 5. At C, x must be 5. All right, so therefore, the length of AC, because it is a horizontal line, it's the y-coordinate at C minus the y-coordinate at A. All right, so that is going to be 5 minus 2, which gives us 3 units. Okay, are there any questions about how we answered question C? Okay, no problem, Amahle. Now, how far down you want me to go? Yolo? You're welcome to unmute and speak. Oh, you've taken your hand down. On Waba, you're welcome to unmute and ask.
Afternoon, ma'am. Oh, evening.
Hi. It's fine. Evening on Waba.
Ma'am, I thought when we get the C coordinates, we use the distance formula in order to calculate the length.
On Waba, you only use distance formula when you are calculating the length of a diagonal line. You don't need to use distance formula to calculate the length of a horizontal line or a vertical line, because a horizontal line is the difference in the x's, a vertical line is the difference in the y's. So you only need to use distance formula when you're calculating the length of a diagonal line. Okay, so in functions like this, it's not distance formula. Okay.
Thank you, ma'am.
All right, no problem. Okay, there is another way that we could have set this particular question out if we wanted to. Do you want me to show you an alternative method, or am I overloading you? How do you feel? You want me to show you another way of doing that? Okay, all right, that's fine, not a problem. Okay, so another way that you can do it is using what I had showed you here in pink up at the top. Okay, because you know that, sorry, there's so much writing all over the place now. I really want to write next to it and I can't. Okay, so because you know, let's do it over here, that actually we're going to use all of that information anyway. Let me just get rid of it and I'll write it again. And then, okay, so an alternative way of being able to do this is using information that you've already got, right? So you know that when a cubic function has a turning point on the x-axis, you know you can use y equals a, x minus x1, x minus x2 squared. We also know the coordinates at B now. All right, because we've worked that out in question B over here. We know that the coordinates at B were 0 and -20. So we have more information. All right. The other thing that we've done is we've also worked out the value of A. We know that A is equal to 1. So we can substitute this in here. So subbing in what we've got, we'll put the 1 over there. X minus x1. So x1 is our x coordinate at C. X minus x2, that has to be the 2 over there, and it has to be squared. So remember, the bracket that gets squared is the x value that is a turning point and an x-intercept. What we can do now is we can sub in this point B. So we can put in -20 over here. 1 times anything is going to give us 1. And we know that at -20 for y, x is equal to 0. So this is another way that you can do it. All right, so -20 is equal to, so we've got x1, and then x1 is going to be multiplied by 4. All right, so 0 minus 2 squared would give us 4. So in other words, we've got 4 times x1 is equal to -20. Divide by 4 on both sides, and that means the x coordinate at C is going to be equal to, oh, hang on a second. Oh, sorry, this was -x. Sorry, so that's -4. And when you divide by -4 on both sides, you would end up with 5. Okay, so that is another way that you could calculate the x coordinate at C, and then you would still have to say 5 minus 2 gives you 3 units. Okay, so that's another way that you could do that question. If you don't like doing the equation, you think that's a bit long or whatever, maybe that's a bit of a shorter way that you could do it. All right, let's just have a look here. YOLO, so when you want the length, you should calculate the x coordinate. Okay, that is if you want the distance between the x-intercepts, then yes, you would do it that way. Okay. Everywhere. Okay, so in other words, what you are doing everywhere is you're working out the value of the brackets. 0 minus x1 is -x1. 0 minus 2 is -2, which is squared. That becomes +4. So +4 times -x is going to give you -4x. Okay, and then you divide both sides by -4, and you would end up with 5 as well. All right, so now somebody's asking for screenshots. Scroll down. Okay, Palesa, not a problem. Is that down enough? Remember, guys, you can always watch the video again. You could fast forward to this particular point if you want to, if you don't want to hear all the other stuff. And then you can, no problem, Palesa. And then you can see how we did this. Okay, so that is an alternative way of being able to answer question C. So we've done A, we've done B, we've done C. The next thing that they want from us are the coordinates of D. All right, so what does D represent for us? What does D represent for us? Matrix? It's a turning point. Lovely, beautiful, everybody. It's a turning point. And how do we calculate the coordinates at the turning points? What do we have to use? What do we use to calculate the coordinates at the turning point? Exactly. First derivative. First derivative. Second derivative is the point of inflection. So it's the first derivative because the gradient at the turning points is 0. Okay, the gradient at the turning points is 0. We've got to use the first derivative. So we know what our equation is. We've got A and B. Okay, we know that A was equal to 1 and that B was equal to -9. Okay, so question D, we take the first derivative. That gives us 3x squared minus 18x plus 24. You have to show that the gradient at the turning point is 0. Okay, this is a common mistake amongst matric students. You have to put the 0 here. Okay, the gradient at the turning point is 0. You must show that it is equal to 0 before you begin to solve your equation. Okay, you get a mark for that 0. It's very important to show that step. Now you can choose. If your factorizing is horrible, use the quadratic formula. If your factorizing is not horrible, factorize. Okay, when you factorize, when you use the formula, make sure that you have shown that you have subbed in. Okay, you cannot just write the quadratic formula on the page and then do all the subbing in on the calculator and write down the answers. You're going to be penalized for that. You have to show your factors or where you've subbed into the formula. All right, so let's try factorizing and just see how it goes. We can divide through by 3. This would give us minus 6x plus 8. This isn't such a bad one. So we would say x minus 2 times x minus 4. So therefore, x equals 2 or x equals 4. And again, we're expecting 2 as one of our answers. We know that already when we look at this, that a turning point happens at 2. But at D, x is not 2. At D, x is equal to 4. Okay, good, Leanne. Yes, lovely. Okay, so this line here, matrix, very, very, very important. Okay, you've either got to show that you've subbed into the quadratic formula. Don't forget on the line where your factors are, it must equal 0. You can't just write the 0 at the once at the top and then just write equals down to the bottom. It must be equal to 0. Okay, there is often an accuracy mark on this line and we end up losing it because we didn't show this step. Okay. All right, so Leanne's given us an answer already. Remember, your x coordinate, sorry, your y coordinate is calculated by subbing your x coordinate not back into the derivative, back into the original function. D is a point that lies on the original function. Okay, so we've got to go and sub it back into our original function. So our original was f of x or y equals x cubed, so that would be 4 cubed minus 9x squared minus 24x, or was it plus 24x minus 20? Let me just check on that. Plus 24. Yes, it was plus 24. Leanne, you say the answer is -4. Let's just double check that. Are the rest of you getting -4 as well? No. YOLO, you can't use that. That formula minus b over 2a is for the turning point of a parabola. You can't use it for a turning point in a cubic function. Okay, so I'm just double checking the answer here, subbing the 4 in. Yes, okay, also getting -4. Yeah. Okay, again, they asked us for coordinates. Let's give them coordinates. Okay, so that means that at D, the coordinates are +4 and -4. And that, again, it makes sense to us because it's a point in the fourth quadrant. We are expecting a positive x and a negative y. Okay, are there any questions on that? Any questions on calculating? I'll just move this down. Aware to, go for it, aware to.
Miss, so every time when we ask to calculate this, we always use this formula.
So you've got to use the first derivative. So if they ask you to calculate the coordinates at the turning point, you have to use the first derivative because the gradient at the turning point is 0.
Yes, Miss. Okay, thank you so much.
Okay, all right, no problem. Okay. And last of all, the coordinates at E. Now remember up here, they told us that E was the point of inflection. Okay, so for the point of inflection, that is when you use the second derivative. Okay, so the first derivative is for the gradient at a particular point. Okay, the gradient at the turning points happens to be 0. Right. When we are speaking about the x-coordinate at the point of inflection, that is where our concavity changes from being, in this case, concave down to concave up. But in a graph where the number in front of the x cubed term is negative, it would first be concave up and then concave down. So this is where our concavity changes, the point of inflection, the second derivative. Now, there are 2 ways to calculate the coordinates at E as well. I don't know if you guys remember this. Let's just scooch over to the side and we'll do it over here. Okay, so for the point of inflection, I'm just going to write this for you as well. So for the point of inflection, we're going to use the second derivative. Maybe what we should do over here for the turning point, let's just put this in black here as well in case you guys come back and watch this. For TPs, use the first derivative. Okay, so we're using the second derivative. Okay. That means that we're going to derive the first derivative again. So our first derivative in this case was 3x squared. I think it was minus 18x plus 24, if I remember correctly. Yes, minus 18x our second derivative would be 6x minus 18. Okay, good. So some of you have already got the coordinates at the point of inflection. That's lovely. If you are doing it this way, all right, concavity is equal to 0 at the point of inflection. So again, you must show that concavity is 0 at the point of inflection. So taking the 6x over to the other side, dividing both sides by -6, we would get that x is equal to 3. Okay, so therefore at E, the x-coordinate is 3. We don't know what the y-coordinate is, right? But we know that the x-coordinate is 3. The other way that you can answer this question is to use midpoint formula, because the point of inflection is always midway between your turning points. Okay, so the other way that you can do this is midpoint formula. Okay, so the x-coordinate at E, remember at A, the x-coordinate was 2. We calculated the x-coordinate at D to be 4. Okay, we're going to divide that by 2. So we've got 6 divided by 2, which gives us 3. Okay, so there are 2 ways to calculate the point of inflection. Again, I think that midpoint formula is a little bit shorter, but it's totally up to you how to do that. Okay, if they now want the y coordinate from us, we've now got to go and sub back into the original equation, which I'll do next. Okay, aware to, you've got a hand up.
Miss, I'm left out. Which tools are we using?
Okay, so this is the 2. Just hold on, I'm just writing back to you, incl. No, you won't be penalized. Sorry, aware to, the 2 and the 4 come from the coordinates at the turning points. So remember, we were given that the coordinates at A was 2 and 0. We calculated the coordinates at D. Do you remember that? Okay,
Yes,
we calculated this to be 4 and -4. So this is where the 2 and the 4 come from.
Oh, yeah. Okay. I remember.
Okay. All right. No problem. Right. And then, as I was saying, to calculate the y coordinate, we've got to go and sub back. And they don't often ask us for the y coordinate at the point of inflection, but you could calculate it as y equals, or f of 3 equals. So that would be 3 cubed minus 9 times 3 squared minus 24 times 3 minus 20. I hope I've remembered that correctly. Okay. Let's just work out the answer to that. I'm getting negative 146. That cannot be right. I must have done something weird here.
It's not net of
Oh, no.
24 plus 24.
I can't see. Oh, plus 24. Sorry, I put minus 24. There we go. There's my mistake.
Yes. Now
Oh, there we go. That's better. That's better. That's better. Sorry, I keep writing it's not minus 24 here. Sorry, it's plus 24. That's the thing. Okay. All right. Is negative 2. Okay. So that, again, they asked us for coordinates. Let's give them coordinates. It's 3 and negative 2. That sounds a lot better than minus 146. Okay. Any other questions that you want to ask me about what we've done this evening? Any other questions about anything that we've looked at? Can you see now how everything gets put together into one question? So it's all this information that they have taught you over a period of time that you now need to assimilate and answer questions all in one go. Okay, Lebogang, go for it.
Oh, evening, ma'am.
Evening.
Ma'am, can I ask, even though the graph may not be drawn to scale, it's still mathematically
Yes, absolutely. So even though it's not drawn to scale, it's still mathematically correct. So in other words, where the lines cut the axes is in the right places. Okay, but you know, if I came along and I drew, you know, a different version of this, as long as I'm cutting over here and there and then there, it really doesn't matter. So this point could be a little bit to the left, it could be a little bit to the right. It doesn't matter. As long as it's to the right of the y-axis, we're okay. As long as this point over here is below the x-axis, we're fine. Okay.